You've seen the pictures of Mercury. It has this giant tail behind it that scientists can't explain. Is it possible that Mercury is hiding its moons in its tail? Well, in this video, we dive deep into the clues left by these moons and unveil the truth behind this celestial mystery. Let's get started.
Ow!
The enigma of Mercury's tail has puzzled astronomers for centuries. This mysterious appendage is only visible in images captured by spacecraft as Mercury makes its close approach to the Sun. And what makes it even more perplexing is that it seems to defy the planet's gravitational pull. You'd think that such a small planet would have an insignificant gravitational influence. But Mercury has managed to surprise us all. Its gravitational force actually extends over 17,000 kilometers from its surface. So why doesn't this force simply pull the tail back towards the planet? Well, it turns out that Mercury's gravitational embrace is not strong enough to dominate its surroundings completely. There are other forces at play here, and they might be coming from an unexpected source. Now let us talk about the leading hypothesis proposed by an international team of researchers led by scientists from the University of Florida. They believe that Mercury has a few large moons that are orbiting around it in a very special way. These moons are thought to be intermediate in size, ranging from around 20 to 80 kilometers in diameter. But where did these moons come from, and how did they end up in Mercury's gravitational embrace? Well, according to the researchers, they were once part of a larger body that was shattered into pieces by a colossal impact early in the solar system's history. This catastrophic event left Mercury slightly off-center and with several large craters. And the debris from this impact never really dispersed throughout the solar system. Instead, it coalesced around Mercury, forming a thin ring of rocks and dust. Over time, gravity did its work, pulling this debris together and forming moons that settled into 3 distinct orbits around the planet. Now, these moons might not be big, but they do have a gravitational pull of their own. And here's where things get interesting. As Mercury whips around the Sun, its moons experience a force known as tidal disruption. This happens when a celestial body's gravity pulls on another body close enough to it, causing it to stretch and distort. And you guessed it, these moons got their tails from this very phenomenon. The gravitational pull of Mercury and the Sun on these moons is so intense that it creates a noticeable distortion, giving rise to these mysterious tails we see in the images. But wait, there's more. These tails are not just some random jumble of rocks and dust. They are actually long-lost parts of the moons themselves. As the moons orbit Mercury, the tidal forces acting on them cause material to be stripped away from their trailing edges. This material doesn't just disappear. It gets incorporated into Mercury's atmosphere through a process called accretion. You see, Mercury's atmosphere is surprisingly dense. It's made up of highly energized particles that glow brightly, creating the beautiful features we observe. In fact, this atmosphere, also known as an exosphere, extends hundreds of kilometers into space. It was previously thought that this exosphere was created by the solar wind. However, the discovery of these mysterious tails has led researchers to believe that these atmospheric features are actually supplied by Mercury's moons. Now, don't worry. We're not just pulling these ideas out of thin air. There's plenty of evidence to support them. Just take a look at Jupiter's moon Io. This moon has a similar tail due to the tidal disruption caused by Jupiter's gravitational pull. Io's tail is even more extreme, stretching over 300,000 kilometers into space. Another example is Saturn's moon Dione. It has a massive tail that was only discovered in 2013, thanks to the Cassini spacecraft. These moons are like real-life examples of what might be happening to Mercury's hypothetical moons. But hold on, because there's one more piece to this cosmic puzzle. Mercury's orbit takes it super close to the Sun, which means these moons are constantly bombarded by solar radiation. This radiation pressure can be pretty intense, and it actually pushes the moons away from Mercury. And guess what? Scientists have observed this phenomenon firsthand when the Messenger spacecraft was exploring Mercury. It saw one of these moons being pushed away from the planet. Now, this discovery might change how we view Mercury's moonless status. If these moons exist, they could help explain some of the mysteries of Mercury's atmosphere and its strange tail. Of course, more research is always needed to confirm these theories. But hey, science is all about asking questions and exploring the unknown. Who knows what other secrets Mercury is hiding? Thank you for watching. Don't forget to subscribe for more updates on all things astronomy. We have a lot more videos in the works that you're going to love. Till next time, keep looking up and stay curious.